This video is going to go through how to determine the inverse of a 3 by 3 matrix. So there's a lot of steps to approaching this, and so I'm going to go through an example right here, and then I'll go through an additional practice problem as well. So let's say we have a matrix. Let's call it's a 3 by 3 matrix, and let's say it's the following. So the first thing I would recommend doing for a question like this is just make sure you rewrite everything correctly, because you're going to be dealing with a lot of numbers and it's easy to mix like a number or a sign up. The first thing we want to do here is determine the determinant of this 3 by 3 matrix. So the determinant of A from a previous video of ours is the following. So remember, we take this and we multiply it by the determinant of this 2 by 2 matrix down here. And then we subtract, well, it's going to be a -1, so it's going to be +1 times -4, 0, 2, and -4. Those are these values, these values right here, here, and here, okay? And then lastly, we're going to subtract 3 times the determinant of this 2 by 2 matrix. So this is the determinant, -4, -1, 0, -4, and 1. Okay, so let's evaluate the determinant. So 3 times, well, this is going to be +4 minus -8, so +8, plus +16 minus 0, minus 3 times +16 minus 0. Okay, and so what we'll get here is this is 3 times 12 plus 16 minus 3 times 16. Well, that becomes 3 times 12 is 36. 16 minus 3 times 16 is minus 2 times 16, which is -32. And so the determinant of the 3 by 3 matrix is 4. Okay, then that's going to come into play later. Now, before we kind of multiply by the determinant, what we need to do is the following. We're going to set up a larger matrix here, where we're going to find several determinants. Okay, and the way it works is we're going to start with the first row in the first column. So first row, first column. The numbers that are left here are going to be the numbers that we're going to determine the determinant of. Okay? So notice we cancel out the first row in the first column, and then we're left with these 4 numbers here, and that's what we're going to find the determinant of. Okay? So let's do the next one. So if we're in the first row, second column, we want the determinant of -4, 2, 0, and -4. So these values right here. Okay, next. We want the first row and the third column. So that's going to be these numbers right here. So -4, -1, 0, -4. Okay, now let's do the next row. So we're going to be dealing with row number 2 now. So we're crossing off the first column and the second row, because that's where we're located right here. And so we end up with -1, -3, -4, -4. Okay. Second row, second column. And so those are going to be the numbers on the endpoints. So 3, -3, 0, -4. second row, third column. So these numbers right here now. 3, -1, 0, -4. Okay, now we're in the last row. So third row, first column. It's going to be everything left here in the top right. -1, -3, -1, 2. Third row, second column. 3, -3, -4, 2. Okay, and then lastly, the third row and the third column. And so what's left are these four numbers over here. So 3, -1, -4, -1. Okay. So before we evaluate the determinant of each of these matrices, we're going to write the following signs. So I'm going to write positive here, negative, positive, negative, positive, negative. So see how it alternates? So positive, negative, positive for the first row, negative, positive, negative for the second row, and then positive, negative, positive for the third row. Okay, and now let's, what we're going to do is evaluate each of these. And we got to pay very close attention to the signs, because we're going to be dealing with a lot of negatives here. So for the first one, remember to evaluate the determinant of a 2 by 2. We go the product of this minus the product of this. Okay, and so the first one is going to be 4, positive 4 minus -8 with a positive on the outside, so that's 12. Okay, next one, 16 minus 0 with a negative on the outside, so that's -16. Positive 16 minus 0 with a positive on the outside, that's 16. 8 minus -12. Sorry, 8 minus positive 12. Sorry, 4 minus positive 12 with a negative on the outside. So 4 minus positive 12, that's -8 with a minus on the outside, becomes positive 8. So it's really easy to mess up the signs here. -12 minus 0 with a positive on the outside, that's -12. -12 minus 0 with a negative on the outside, that's positive 12. -2 minus 3 with a positive on the outside, that's -5. 5 plus 12, well, it's 5 minus positive 12, so it becomes 5 minus 12. Sorry, 6 minus 12 with a negative on the outside. So this is positive 6. And then -3 minus positive 4. And so that's -7. So again, super easy to match. Like, I think this step to this step is one of the trickier ones when you're doing these, because there's so many terms that you have to deal with. Okay, so we're almost done, but we need to do a couple more things. What we're going to do here is we're going to take this diagonal and we're going to switch the location of all of the numbers. We're essentially going to reflect this matrix over this diagonal. So the numbers in the diagonal are going to stay the same, but for example, the -5 and the 16 are going to switch. And the 8 and the positive 6, and the 8 and the -16 are also going to switch. So the diagonal in the front stays the same. The 16 and the -5 will switch. These are going to switch. So -16, positive 8. These are also going to switch. So 12 and then positive 6. Okay, we are almost done. And the last thing we're going to do here is we're going to take this new matrix, and the inverse is defined as 1 over the determinant of A, which we already calculated, times this matrix right here. So our answer is going to be a 3 by 3 matrix, and we're going to determine what that matrix is by taking the determinant, 1 over the determinant, which is 1/4, and then multiplying it by this new matrix right here. Okay, so let's multiply 1/4 through, and so the, I'll write it down here, the inverse of our original matrix is, this will be 3, 2. Remember, if we multiply a matrix by a scalar number on the outside, we just take that scalar and multiply it to each individual element in the matrix. So 3, 2, minus 5 over 4. Negative 4. Negative 3. This is really 6 over 2, which is 3 over 2. And then if we take the 1/4, let's rewrite this one. If we take the 1/4 and multiply it by the 16, that's 4. 3 is 1/4 times 12, and then lastly, negative 7 over 4. And so this right here is our inverse matrix, and this is the answer for this first question. Okay, so it's a lot of steps, but I'll go through one more just to give you a little bit more reference when you're trying to practice these. So problem number 1. Okay, problem number 1. So same thing with the last question. The first thing we want to do is find the determinant of this matrix. So it's a 3 by 3 matrix, and we're going to call this matrix A. Same as last question. So the determinant is going to be 2 times the determinant of this 2 by 2 matrix right here. So we're dealing with these two quantities. So 3, 2, negative 4, 4. And then we're going to subtract 0 times the determinant of this 2 by 2 matrix. So negative 1, 2, negative 4, and then 4. And then lastly, we're going to add negative 2 times the determinant of this 2 by 2 matrix. So negative 2 times negative 1, 3, negative 4, and then negative 4. Okay? So the nice thing about this one is the middle term is multiplied by 0, so that's just going to go away if it becomes 0. And so let's simplify this. So 2, 3 times 4 is 12, minus negative 8, that's 12 plus 8, minus 2 times 4, minus negative 12, so that's plus 12. So we get 2 times 20, which is 40, minus 2 times 16, well that's 32, and so 40 minus 32 is 8. So the determinant of this matrix is 8, and that's going to go on the outside for this, for finding the inverse. Okay, so now this is the hard part, is evaluating this larger matrix. So if we want to figure out the term that's in the top left, we're dealing with the first column and the first row, and so we're going to be using this matrix right here. So we're going to be using 3, 2, negative 4, and then positive 4. So that's the top left. The next determinant is going to be the first row and the second column. So we want this 2 by 2 matrix, or determinant. So negative 1, 2, negative 4, positive 4. Okay? To wrap up the first row, we're dealing with the first row and the third column. And so we want this matrix right here. So negative 1, 3, negative 4, negative 4. Okay, so that's the first row. Let's go through the next two rows. So we want second row, first column. So the second row in the first column is going to be 0, -2, -4, +4. Okay. Second row, second column. These are going to be the numbers in the corners. So 2, -2, -4, and then 4. Okay, and then to wrap up the second row, it's going to be second row and then the third column. Right here. Oops. So this 2 by 2 determinant. 2, 0, -4, -4. Okay. And then the last row. So we're dealing with the third row. So third row, first column. This 2 by 2 matrix. 0, -2, 3, 2. Third row, second column. So that's going to be this 2 by 2 matrix. 2, -2, -1, 2. Okay, almost done. And then the last one's going to be the third row and the third column. So 2, 0, -1, and then 3. Okay, moves a little bit over here. So next, we're going to change the signs here. So this is plus, minus, plus. The second row is minus, plus, minus. And then the third row is plus, minus, plus. Okay, and now, like I said before, I think going from this step to this step is going to be the trickiest because you are most prone to having those algebraic mistakes because you're dealing with so many negatives and changes of signs. Okay, so let's evaluate this. So for the top left, we have positive on the outside, 12 minus -8, which is positive 20. So first row, second column. -4 minus -8 is -4 plus 8 with a negative on the outside. So that's -4, which is, or it's -4, just -4. Positive 4 minus -12, that's 4 plus 12, so it's 16. This one is 0 minus positive 8. So that's -8 with a minus on the outside. So it's 8. Okay, so again, with the signs, these get kind of tricky. So then the middle one is going to be 8 minus positive 8. So that's 0. This one will be -8 minus 0. So it's positive 8 because there's a negative on the outside. Bottom left is going to be 0 minus -6, so that's just positive 6. 4 minus 2 with a is 2 with a negative on the outside is -2. Okay, and then lastly, this one's nice because it's just 6 minus 0, so it's a 6. Okay. Okay, so now we're going to draw a little line right here. And then we're going to switch the locations. We're basically going to reflect this over this dotted line. So the numbers inside the line are going to stay the same. And then the 6 and the 16 are going to switch locations. The 8 and the -4 here. So -4, 8, -2, and then 8 is over here. Okay? And now we're almost done. So now to find the inverse, we're going to take this, and the inverse of A, defined like this, is going to be 1 over the determinant of the matrix A times this matrix right here. So last thing we're going to do is plug in the determinant. So 1 over 8 times this whole thing. Okay, and then we're going to multiply 1 over 8 through. So the inverse is equal to, so remember when we're multiplying a scalar by a matrix, we just multiply each element in the matrix by that scalar. So 20 divided by 8, that's the same thing as 5 over 2. 8 over 8 is 1. 6 over 8 is 3/4. Negative 4 over 8 is negative 1/2. Let me make this a little bit bigger. 0 over 8, that one's nice, it's just 0. Negative 2 over 8 is negative 1/4. 16 over 8 is 2. 8 over 8 is 1 again. And then 6 over 8 is 3 over 4. And so this is the inverse matrix of our original matrix at the top. Okay? So when you're finished with this video, I want you guys to go through problem set number 2, or problem number 2, right here. And the key will be below, and then when you're finished with that, go through the additional practice as well.